We already know that the files on our computing devices are simply collections of binary numbers, just like this one. More than that, we know that if the file we're looking at is an application file, an exe file, then these bytes that make up the file represent a combination of instructions and data. But we also know that to program an application directly in this machine code is extremely difficult. And so we have developed computer languages to help in this process. Here is the assembly language that produced this machine code. Assembly language is much easier to understand and much easier to program in than machine code. And then we can go one step further. We can look at higher level languages. And here is an example of Visual Basic. It was this higher level language that was used to produce this machine code originally. But the question is, how do we get from assembly language into machine code, or from a higher level language into machine code? And the answer is, we use a translator. The sole purpose of a translator is to convert either assembly language into machine code, or to convert a higher level language into its equivalent machine code. And we have three different types of translator that we commonly use. The first is called an assembler. Then we have compilers, and then interpreters. Of these three, the most straightforward one to understand is an assembler, because an assembler simply takes assembly language and rewrites it as machine code. So it takes all of these little mnemonics that will have been written by the programmer and changes them into the specific bytes for each of these instructions. But there's something quite important about assemblers. In our daily lives, we actually use a wide variety of processors. If you're using a PC at school, for example, then that PC will contain one type of processor, probably one of the more complex types of processor that we come across. However, if we're using a washing machine, that washing machine will also contain a processor, but it will be a much simpler processor with a much simpler job to do. What this means is that different processors have different instruction sets. In other words, if we write a program with one set of instructions relevant to a washing machine, then the PC's processor won't be able to understand a lot of that, because the processor that is in our washing machine needs one set of instructions, whilst the PC has a processor that has quite a different set of instructions. It may be that there are similarities between the two, but more importantly, there are key differences. So when we program in assembly language, we make sure that we use the version of assembly language relevant to that processor that we are programming for. And that means that we need an assembler that is dedicated to that assembly language, and therefore to that particular processor. So there are a wide range of assemblers, just as there are a wide range of processors that we come across today. Then we move on to higher level languages, and if we want to translate a higher level language into its machine code, then we have two options. We can use either the compiler or the interpreter, and we'll actually be looking at the difference between these two in the next video. For now though, the important thing to understand is that a program written in a higher level language can then be compiled to work on a variety of different processes. For example, this program, written in Visual Basic, was compiled so that it would run on the processor in my PC. But equally, I could compile it again using a different compiler so that it would run on a different type of processor, for example, for an Apple Mac. So the advantage of writing programs in higher level languages is that we can then translate them into the machine code for different processors. Whereas when we write in assembly language, we use the assembly language specific to a particular processor.